Alright, cosmic voyagers, pull the metaphorical covers up to your chin. Or, if you're already there, just relax a little deeper into whatever surface is currently cradling your weary human form. Another day spun to a close on this rather frantic little planet, hasn't it? Full of its usual cacophony, its urgent little demands, its endless, chattering anxieties. It's enough to make one yearn for the profound, uncomplicated silence of, well, almost anywhere else, really. Tonight we're setting a course for such a place. Or, at least, a place that promises a certain kind of silence, a certain kind of profound mystery. We're leaving behind the terrestrial squabbles, the flickering screens, the existential dread that comes from knowing your Wi-Fi password but not the grand unified theory. Instead, we're journeying to a small, icy moon, a distant, gleaming pearl caught in the colossal gravitational dance of the solar system's undisputed heavyweight champion, Jupiter. Our destination, my sleepy friends, is Europa. Just saying the name Europa feels cool, doesn't it? Like a sliver of ice melting on the tongue. And from a distance, it certainly looks the part. Imagine a perfectly smooth ivory sphere, catching the faint, faraway sunlight and reflecting it back with a cold, pure brilliance. It's one of Jupiter's 4 largest moons, the Galilean moons, discovered by Galileo Galilei himself way back in 1610, when looking up at the sky was less about avoiding drone traffic and more about, well, discovering entire new worlds with a rickety telescope. Good old Galileo. He probably didn't imagine we'd be using his discovery as a cosmic sleep aid, but then the universe is full of surprises, isn't it? Mostly unpleasant ones, but let's not get ahead of ourselves. Europa is the 6th closest moon to Jupiter, and the smallest of these 4 famous siblings, Io, Europa, Ganymede, and Callisto. Think of them as the royal court attending their immense, swirling, gaseous monarch. Io, the volcanic, sulfurous, perpetually tortured one, the court jester who's clearly not having a good time. Ganymede, the largest moon in the entire solar system, bigger even than Mercury, the stoic, oversized bodyguard. Callisto, ancient and heavily cratered, the wise old vizier, seen it all, done it all, and frankly, a bit bored by now. And then there's Europa, the smooth, enigmatic one. The ice princess, perhaps. Or, as we're beginning to suspect, the one with a very, very deep secret. You see, that smooth, icy surface, which looks so serene from afar, is a lie. A beautiful, intricate, frozen lie. As we drift closer, you begin to see that it's not perfectly smooth at all. It's covered in a complex network of streaks and ridges, long, dark lines crisscrossing its face like a shattered windscreen, or the frantic scribblings of a cosmic artist who's had a bit too much ambrosia. These are called lineae, and they hint at something truly extraordinary. They suggest that this icy shell isn't static. It's moving. It's cracking. It's being pulled and stressed by forces beyond our everyday comprehension. And what could cause such global-scale fracturing on a world otherwise encased in ice kilometers thick? Well, that's where the tantalizing, the truly mind-bending possibility comes in. Beneath that shell of ice, perhaps 10, perhaps 100 kilometers thick, we're still sketching in the details, you understand. Scientists believe there lies an ocean. A vast, global ocean of liquid salt water. Think about that. An entire world encased in ice, but with a hidden, sloshing liquid heart. More water, potentially, than all of Earth's oceans combined, tucked away under a frozen blanket, in the chilling shadow of Jupiter. It sounds like science fiction, doesn't it? Cliché almost. The hidden ocean on the ice moon. But the evidence, as we'll explore, is compelling. And with the existence of liquid water, that precious, life-giving solvent, comes the inevitable whispered question. Could there be life? Not little green men waving hello, mind you. Our imaginations tend to get a bit carried away with the whole alien shtick. No, something more fundamental, perhaps. Something microbial. Or perhaps something that's had a few billion years to evolve in utter darkness, under crushing pressure, fueled by chemical energy seeping from the moon's core. What might that look like? Try not to picture it too vividly if you're prone to aquatic nightmares. The universe, after all, has no obligation to make its inhabitants cute and cuddly, or even visible without a very powerful and probably very specialized microscope. So there she hangs in the void, Europa. A gleaming, cracked bauble humming with this incredible, almost outrageous potential. It's a place that invites us to dream, to wonder, but also to confront the sheer, stark alienness of the cosmos. It's a place where the promise of discovery is laced with the very real understanding that the universe is rarely gentle, rarely straightforward, and almost never concerned with our delicate human sensibilities. It's a challenge wrapped in an enigma served cold. Very, very cold. Settle in now. Let your breath slow. We're just beginning our approach. The journey to Jupiter is a long one, and Europa isn't exactly handing out free tourist brochures. But the thought of it, this frozen sphere with its secret watery heart, is a peculiar kind of lullaby, isn't it? A Jovian lullaby, sung by the relentless pull of gravity and the faint crackle of radiation. A song of ice and darkness, and the profound, unsettling yet deeply compelling possibility of an ocean teeming, or terrifyingly empty far, far from home. Let that possibility cradle you as we drift onwards. We are now coasting, a tiny speck of intention in an ocean of indifferent vacuum. The initial burn, the escape from Earth's familiar embrace, is long past. That blue marble, with all its noise and warmth and overly complicated social rituals, is shrinking behind us, a dwindling beacon of the known. Ahead lies the great dark expanse of the interplanetary void, a silence so profound it feels less like the absence of sound and more like a presence in itself. You are suspended, weightless, a passenger on a vessel of dreams and meticulously calculated trajectories. The journey to Jupiter is not a quick jaunt. It's not a weekend getaway. We're talking years. Several of them. Imagine, if you will, sealing yourself in a rather sophisticated, but ultimately very small, tin can for half a decade or more. The initial excitement of launch, the thrill of seeing Earth recede, would eventually give way to a different kind of appreciation for the cosmos. A deeper, more monotonous kind. The kind that makes you really, really appreciate a good book, or a particularly engaging screensaver. Or perhaps, the slow, methodical unraveling of your own sanity. Just kidding. Mostly. Out here, time takes on a different quality. The familiar rhythm of day and night, dictated by the spin of our home planet, dissolves. There is only the perpetual twilight of deep space, punctuated by the distant, unwavering pinpricks of stars. The sun itself, our usually boisterous and life-giving star, begins to appear, diminished. Still brilliant, of course, still the dominant source of light, but smaller, less overwhelmingly present. It's like watching a bonfire recede as you walk away into a cold night, its warmth becoming a memory, its light a focus point rather than an enveloping glow. This subtle dimming is a constant reminder of your increasing distance from the familiar, a slow visual unfurling of the sheer scale we're traversing. Your companions on this journey? The quiet hum of life support, the occasional, almost apologetic course correction thruster firing, and the ever-growing presence of Jupiter itself. At first, it's just another bright point of light among many, distinguishable mainly by its steady, unwavering shine compared to the twinkling stars. But week by week, month by month, it grows. It resolves from a point into a disk that then begins to show features, faint bands, subtle swirls of color. The great red spot, that centuries-old, planet-sized storm, might make an appearance, a swirling crimson eye in the vast face of the gas giant. There's a certain grim beauty to this. The universe isn't putting on a show for you. It's just being. And you happen to be drifting through it. The entertainment value is entirely self-generated. You could spend your days poring over scientific data, running system diagnostics, or perhaps engaging in some spirited debate with your crewmates about whose turn it is to clean the recycled water filter. Or you could simply stare out of the viewport, watching Jupiter loom larger, feeling the subtle, almost imperceptible gravitational pull of this immense being, a pull that is slowly, patiently drawing you into its domain. It's a journey that strips away the superfluous. Out here, your worries about unpaid bills or awkward social encounters tend to lose their sharp edges. They're still there, perhaps tucked away in the mental luggage, but they're dwarfed by the sheer, humbling emptiness around you and the monumental destination ahead. It's a kind of enforced mindfulness, really. The universe's way of saying, oh, you think that's a problem? Look at this. And this is a planet so large it could swallow Earth 1,000 times over, a swirling maelstrom of gases and pressures so extreme they defy easy comprehension. Makes that overdue library book feel a little less cataclysmic, doesn't it? The silence, as I mentioned, is pervasive. Not just the lack of sound waves traveling through a vacuum, but a deeper existential silence. You could scream and only the internal bulkheads of your ship would register it. The universe wouldn't flinch. It wouldn't even notice. There's a certain stark comfort in that, perhaps. A release from the pressure of being heard, of making an impact. You are, for these long years, simply a witness, a mote of dust with a very sophisticated navigation system, drifting towards an encounter with one of the solar system's titans. And Jupiter, oh Jupiter. It's not just big, it's powerful. Its magnetic field is a monstrous, invisible bubble extending millions of kilometers into space, trapping charged particles and accelerating them to tremendous speeds. This creates an intensely radioactive environment around the planet, a cosmic hazard zone that our little ship will have to navigate with extreme care. It's a reminder that even at this distance, even before we truly enter its sphere of influence, Jupiter is a force to be reckoned with. It's not just a pretty picture in a telescope, it's an active, dynamic, and frankly rather dangerous entity. A king whose court is beautiful, but also fiercely protected by invisible, energetic sentinels. So you drift, you watch, you wait. The days blur into a rhythm of system checks, scientific observations, and the quiet contemplation of the immense journey still ahead. The sun shrinks. Jupiter grows. The stars remain cold and distant. It's a slow, meditative process, this coasting through the dark. A kind of deep space hibernation of the soul, preparing you for the wonders and the potential terrors that await in Jupiter's chilly court. Let the hum of the imaginary engines be your mantra, the receding earth a fading concern, as you surrender to the long, slow drift towards Europa, nestled under the vast, brooding gaze of its giant. And so, after what feels like an eternity spent traversing the interplanetary gulf, a slow, patient surrender to the laws of orbital mechanics, we arrive. Not with a bang, not with a triumphant fanfare. The universe rarely indulges in such theatrics for our benefit, but with a series of precise, calculated engine burns. Our little vessel, a marvel of human ingenuity and an astonishingly fragile speck against the backdrop of cosmic immensity, gracefully, carefully, inserts itself into orbit around Europa. The long coast is over. We are now a satellite of a satellite, caught in the intricate gravitational waltz of the Jovian system. From this new vantage point, Jupiter is no longer a distant, growing disk. It is a colossal, overwhelming presence that dominates a vast swathe of the sky. Imagine looking up and seeing not a familiar blue expanse or a star-dusted night, but a swirling, banded behemoth of gas, so large it seems to break the very concept of sky. Its subtle hues of cream, ochre, and rust fill your vision, a dynamic canvas of storms and jet streams. The great red spot, if visible, would be an awe-inspiring, terrifying vortex, a hurricane wider than our entire home planet, churning with an ancient, implacable fury. You feel small, very, very small, and perhaps a little bit like you've overstayed your welcome at a particularly grand and slightly menacing royal court. But our focus, our destination is Europa. And there it is, hanging beneath us, or perhaps above or to the side. Orientation becomes a rather fluid concept out here. It's no longer the distant ivory pearl. It's a world, a sphere of frozen, fractured light. The surface, as we draw closer, resolves into that characteristic network of reddish-brown lines, the lineae stark against the brighter, icy plains. It looks like someone took a giant ball of white clay and then, in a fit of pique, scribbled all over it with a rusty nail. These aren't gentle, artistic flourishes. They're evidence of immense stress, of a surface that has been and continues to be torn apart and reformed. This is not a welcoming landscape, not in the terrestrial sense. There are no rolling green hills, no sparkling blue oceans open to the sky, no friendly beachfront properties. This is an ice world through and through. The temperature on Europa's surface hovers around a bracing minus 160 degrees Celsius, that's about minus 260 degrees Fahrenheit, at the equator, and plummets even further towards the poles. You wouldn't want to step out for a casual stroll without some rather specialized outerwear. And by specialized, I mean a full-fledged, heavily insulated, radiation-shielded spacesuit, and even then you'd probably want to make it a quick trip. And then there's the radiation. Oh, Jupiter's little gift to its inner moons. As we mentioned, Jupiter's magnetosphere is a particle accelerator on a planetary scale. It traps electrons and ions, whipping them around at incredible speeds, creating belts of intense radiation. Europa, unfortunately, orbits deep within these belts. The surface of this moon is constantly bombarded with a lethal shower of charged particles. Enough to fry any unprotected electronics in short order, and certainly enough to do very unpleasant, very permanent things to any biological organisms foolish enough to sunbathe there. If there's life on Europa, it's most certainly not frolicking on the surface, soaking up the Jovian rays. That would be a very short and very sizzled existence. So we are, in essence, skating on thin radioactive ice. Thin being a relative term, of course. The ice shell itself is thought to be many kilometers thick. But thin in the sense that it's the only barrier between the lethal radiation bath on the outside and the potentially life-harboring ocean on the inside. It's a stark reminder of the universe's casual brutality. Here is this moon, potentially holding one of the greatest secrets of existence, an alien ocean, perhaps life, and its surface is simultaneously a beautifully scarred work of art and a death trap. The cosmos, it seems, has a rather twisted sense of aesthetics and hospitality. Come for the views, stay because you've been irradiated into a fine paste. Yet, despite the harsh conditions, or perhaps because of them, Europa is utterly captivating. The way the faint sunlight, already weakened by its long journey from the sun, catches the ridges and plains, creating a landscape of subtle shadows and ethereal glows. The sheer, stark alienness of it. There's a purity to its hostility, a cold, uncompromising beauty. It doesn't pretend to be something it's not. It is ice and radiation and mystery, all bound together by the relentless gravity of its giant parent. As our imaginary craft glides silently above this fractured, frozen world, you might feel a strange mix of awe and a creeping sense of unease. Awe at the scale and the otherworldly beauty. Unease at the profound indifference of this environment to your existence, to any existence. It's the kind of beauty that makes you acutely aware of your own fragility, your own warm, soft, easily damaged biology. It's the beauty of a perfectly crafted razor blade, or a flawlessly toxic flower. Mesmerizing but best appreciated from a safe distance. Or, in our case, from within the heavily shielded confines of our orbital sanctuary, as we prepare to contemplate the even deeper, darker mysteries that lie beneath this beautifully hostile, radioactive veneer. Let the silent, cold majesty of Europa fill your mind, a stark and stunning prelude to the descent into its hidden heart. We now turn our attention, our imaginary sensors and our deepest contemplation, to Europa's most prominent and defining feature, its icy shell. This isn't just a thin skim of frost on a rocky core, like some celestial sugar dusting. No, this is a substantial, planet-circling carapace of water ice, a frozen shield kilometers thick, perhaps tens of kilometers. Imagine all the ice in Antarctica and Greenland, multiply it several times over, and then wrap it around an entire world. That gives you some sense of the scale we're discussing. It's a formidable barrier, a planetary fortress of solitude, guarding the secrets that may or may not lie within. From our orbital perch, we see the evidence of this shell's dynamic nature etched across its entire face. Those reddish-brown streaks, the lineae, are the stars of the show. Some stretch for thousands of kilometers straight as a ruled line, while others are more curved and jumbled. They are, essentially, cracks. Giant, world-spanning cracks in the ice, like the seams on a very old, very stressed baseball. The reddish-brown color is thought to be due to salts and sulfur compounds, perhaps dredged up from the ocean below and then cooked by Jupiter's relentless radiation. It's as if the moon is bleeding minerals from its wounds, a constant, colorful reminder of the forces at play. Then there are the more chaotic regions, aptly named chaos terrain. Imagine taking a vast sheet of ice, smashing parts of it with a cosmic hammer, letting the pieces refreeze in a jumbled, angular mess, and then doing that over and over again across huge swathes of the surface. That's chaos terrain. It looks like giant icebergs tilted and frozen in place, amidst a matrix of smoother, refrozen material. These areas are particularly intriguing to scientists because they suggest places where the icy shell may have thinned, or even melted through completely at some point in the past, allowing liquid water from below to well up and interact with the surface before refreezing. They are, perhaps, fossilized wounds, scars from moments when the ocean breached its icy prison. Or, if you're feeling less romantic, just a really messy bit of planetary geology. The universe isn't always tidy. Think about the pressures involved here. The ice itself, kilometers thick, exerts enormous weight. And beneath it, potentially, a vast ocean pushing back. And all of this is being constantly flexed and stretched by Jupiter's gravity. It's a recipe for geological restlessness on a grand scale. This isn't a dead, static sheet of ice. It's a living, in a geological sense, calm down, tectonic system, with plates of ice that might be shifting, subducting, and spreading much like Earth's rocky tectonic plates, but made of water ice instead of silicate rock. A cryogenic plate tectonics, if you will. Just when you thought geology couldn't get any cooler. Or, well, it literally can. The surface isn't just fractured, it's also surprisingly smooth in places, particularly in the younger regions. Europa has relatively few impact craters compared to its heavily pockmarked sibling, Callisto, or even our own moon. This lack of craters is a huge clue. It means the surface is being constantly resurfaced. Old craters get erased, filled in, or broken apart by the movement of the ice. It's like a planetary Zamboni, slowly smoothing over the blemishes, driven by the internal heat and the upwelling of fresh, or at least fresher, ice from below. This resurfacing process could take millions of years, which is a blink in cosmic time, but it points to an active, ongoing process. The moon is constantly giving itself a facelift, hiding its age and its history under fresh layers of frozen water. Terribly vain for a celestial body. Imagine standing on that surface, heavily protected, of course. The ground beneath your feet would be ice as far as the eye could see. Hard, brittle, and under unimaginable stress. You might see towering ridges formed where plates of ice have collided, or deep, dark gashes where they've pulled apart. The sky above would be dominated by that colossal, swirling bulk of Jupiter, a constant, silent overseer. The silence would be absolute, save for the hum of your suit systems and perhaps, if you listen very carefully, the faint, unearthly creaks and groans of the ice itself, shifting and straining under the tidal forces. It would be an experience of profound isolation, standing on a fragile crust above a hidden world, bathed in radiation, under the gaze of a gas giant. Makes your average Tuesday morning commute seem positively serene, doesn't it? This icy shell is both a barrier and a promise. It's a barrier because it makes accessing the potential ocean incredibly, monumentally difficult. We can't just dip a bucket in. We have to figure out how to get through kilometers of this stuff. But it's also a promise because that very same ice, if there's an ocean beneath it, acts as a shield. It protects the liquid water from the harsh radiation of space, and it insulates it from the extreme cold of the surface. It's the lid on the cosmic petri dish, keeping the potential experiment contained and just maybe viable. So, as you drift into a state of deeper relaxation, picture this scarred, dynamic yet strangely beautiful face of Europa. This frozen diary of an ocean's restless heart. Each crack, each ridge, each chaotic jumble of ice is a sentence, a paragraph, in a story that has been unfolding for billions of years, a story of pressure and cold, and the persistent, mysterious warmth from within. A story written in the language of fractured ice, hinting at the liquid narrative hidden just out of sight, just beneath the surface. Now let's address the rather crucial question of why. Why would a small, icy moon, so far from the sun's relatively feeble warmth at that distance, possess a vast, liquid ocean beneath its frozen skin? The answer, my sleepy friends, lies not with Europa itself, but with its colossal, overbearing, and frankly rather grabby neighbor, Jupiter. The key is a phenomenon known as tidal heating, and it's essentially Jupiter giving Europa a relentless, deep tissue massage, whether Europa particularly wants one or not. A cosmic spa treatment with rather significant geological, and potentially biological, side effects. Imagine holding a squash ball in your hand and repeatedly squeezing and relaxing your grip. The ball flexes, it deforms, and if you do it vigorously enough for long enough, it will start to warm up due to the internal friction. Now scale that up. Europa is the squash ball. Jupiter, with its immense gravitational field, is the hand. And the squeezing isn't just a gentle pulse, it's a constant, rhythmic kneading. You see, Europa's orbit around Jupiter isn't perfectly circular. It's slightly elliptical, meaning its distance from Jupiter varies a little as it goes around. Furthermore, Europa is also gravitationally nudged and pulled by the other large Galilean moons, particularly Io and Ganymede, in a complex orbital dance called a Laplace resonance. This means that for every orbit Ganymede makes, Europa makes 2 and Io makes 4. It's a beautifully precise cosmic clockwork, but for Europa, it means its orbit is constantly being perturbed, preventing it from settling into a perfectly circular path. This is key. Because its orbit is elliptical, the strength of Jupiter's gravitational pull on Europa changes continuously. When Europa is closer to Jupiter, the pull is stronger. When it's farther away, the pull is weaker. This varying gravitational force causes Europa to bulge and stretch. The side of Europa facing Jupiter is pulled more strongly than the far side, creating a tidal bulge, much like how our moon creates tides on Earth. But because Europa's distance and orientation to Jupiter are constantly changing due to that elliptical, resonant orbit, this bulge is constantly shifting, being kneaded across and through the moon's interior. This constant flexing, this internal friction generates heat. A lot of heat. Enough heat, scientists calculate, to maintain a significant portion of Europa's interior in a liquid state, even though the surface temperatures are frigid enough to freeze nitrogen solid. It's a remarkable cosmic balancing act. The cold of deep space on the outside, the internal heat generated by gravitational friction on the inside, and a thick insulating layer of ice in between. The result? A potential ocean warm enough to be liquid, sandwiched between a frozen roof and a rocky, heated floor. It's quite an elegant solution really to the problem of keeping water liquid so far from a star. The universe, it turns out, has more than one way to light a fire, or in this case, melt an ocean. It doesn't always need direct sunlight. Sometimes all it needs is a sufficiently massive bully planet and a small, obligingly flexible moon caught in a gravitational tug-of-war. It's a less glamorous heat source than a roaring sun, perhaps. More of a slow, grinding, internal burn. But if it does the trick, who are we to complain? Although, from Europa's perspective, it might feel less like an elegant solution and more like being perpetually caught in a cosmic vice. Oh good, another few million years of being squeezed. My favorite, Europa might grumble if moons could grumble. This tidal heating isn't unique to Europa, by the way. Its volcanic sibling Io experiences even more intense tidal heating, making it the most volcanically active world in the solar system, a hellish landscape of sulfurous eruptions. Ganymede and even distant Callisto might experience some tidal heating too, perhaps enough to sustain subsurface oceans of their own, though likely deeper down or slushier. But Europa seems to be in a Goldilocks zone for tidal heating. Not too much to boil away its water or turn it into a volcanic nightmare like Io, but just enough to maintain that tantalizing liquid layer beneath the ice. So, as you nestle deeper into your pillows, imagine that relentless gravitational dance. Jupiter, the immense, swirling giant, its gravity reaching out across hundreds of thousands of kilometers. Europa, the smaller moon, caught in that inescapable embrace, its very substance being flexed and stressed, generating a hidden warmth in the cold darkness. It's a silent, powerful process, unfolding on a planetary scale, a constant reminder that the universe is a place of immense forces and subtle interactions. The same forces that hold galaxies together, that guide the paths of planets, are here on a more intimate scale, needing a small moon and, in doing so, creating one of the most promising environments for finding life beyond Earth. It's a cosmic engine, fueled by gravity, churning away in the outer solar system, with Europa's hidden ocean as its remarkable and deeply mysterious product. A testament to the fact that even in the coldest, darkest corners of space, the right kind of pressure can quite literally make worlds. So we have this compelling theory: Jupiter's relentless gravitational squeeze is warming Europa from the inside out, maintaining a vast, hidden ocean. A lovely idea, makes for good science fiction, even better bedtime stories. But scientists, bless their skeptical, evidence-demanding hearts, aren't usually content with just a good story. They like proof. Or, failing that, some really strong hints. And Europa, in its own enigmatic way, has been offering up a few of these whispers from below, subtle clues that suggest the theory isn't just wishful thinking. One of the most significant pieces of evidence comes from Europa's magnetic field, or rather, its lack of a permanent, self-generated one, and how it interacts with Jupiter's colossal magnetosphere. The Galileo spacecraft, during its many flybys of Europa in the late 1990s and early 2000s, made a fascinating discovery. As Europa orbits Jupiter, it passes through Jupiter's powerful magnetic field. And this interaction induces a secondary, weaker magnetic field within Europa. This induced field is precisely what you'd expect if there were a significant layer of electrically conductive material hidden beneath the icy surface. And what's a really good, naturally occurring electrical conductor that we know might be present in vast quantities on Europa? You guessed it, salt water. A salty ocean. Think of it like this: Jupiter's magnetic field is like a giant, rotating bar magnet. As Europa moves through the lines of this magnetic force, if it contains a conductive layer, like a global saltwater ocean, electrical currents are generated within that layer. These currents in turn create their own magnetic field, Europa's induced field. The Galileo magnetometer detected this field, and its characteristics, its strength, its orientation, strongly suggested that the conductive layer is relatively close to the surface, within a couple of 100 kilometers, consistent with the ice shell thickness estimates, and that it's global. It's not just a localized pond, it's an ocean wrapping around the entire moon. This magnetic signature is one of the cornerstone pieces of evidence for Europa's subsurface sea. It's like Europa is inadvertently sending out a faint, magnetic Morse code saying, "Yes, I've got a salty secret down here." A very subtle, very geeky kind of confession. Then there are the plumes. Are the plumes? The possibility of Europa actively spewing jets of water vapor and ice particles from its surface into space is incredibly exciting. Why? Because if these plumes originate from the subsurface ocean, they are essentially free samples. Nature's own biopsy, delivered right to our cosmic doorstep, no drilling required. How wonderfully convenient. And potentially messy if you're flying too close. Evidence for these plumes has been a bit more fleeting, a bit more now you see it, now you don't, which is frankly very on brand for Europa. The Hubble Space Telescope has, on a few occasions, detected hints of what appear to be water vapor erupting from Europa's southern hemisphere. These observations are at the very limit of Hubble's capabilities, so they come with a fair bit of scientific caution. More recently, reanalysis of old Galileo spacecraft data has also suggested that the probe might have unknowingly flown through one of these plumes back in the day. Imagine that, barreling through a jet of alien ocean water at tens of thousands of kilometers per hour and not even realizing it at the time. The universe has a funny way of revealing its secrets, often decades after the fact, hidden in some dusty archive of magnetic field data or plasma wave signatures. Oh, by the way, the old data whispers, you touched the alien ocean. Hope you washed your hands. If these plumes are real, and if they are indeed sourced from the ocean, they could be ejected through temporary cracks or fissures in the ice shell. Perhaps where the ice is thinnest, or where tidal stresses are particularly intense. They wouldn't be continuous, old faithful-style geysers, most likely. More like intermittent, powerful bursts. Europa occasionally and rather dramatically burping up its dinner. Or, if you prefer a less gastronomical analogy, venting some of the immense pressure built up within. These plumes, if confirmed and characterized, would be a game-changer for future missions. A spacecraft could potentially fly through them, collect samples of the ejected material, and analyze its composition right there in space or even bring it back to Earth. We could look for salts, organic molecules, and the holy grail, signs of life, all without the monumental, eye-wateringly expensive and technically nightmarish challenge of drilling through kilometers of solid ice. It's the universe offering a tantalizing shortcut. Of course, knowing the universe's penchant for irony, these plumes will probably only erupt when our spacecraft are looking the other way, or when their instruments are inexplicably on the fritz. Missed it by that much. Try again in another decade, Earthlings. So we listen. We listen with our magnetometers for the subtle hum of an induced magnetic field. We watch with our telescopes and our reanalyzed data for the ghostly signature of water vapor erupting into the blackness. These are Europa's whispers, faint and sometimes ambiguous, but they are building a compelling case. They speak of a dynamic hidden world, a world that isn't entirely sealed off, a world that might, just might, be breathing its secrets out into the void. Let these subtle clues, these faint promises from a distant, icy moon, deepen your relaxation, as we ponder the profound implications of an ocean that not only exists, but also occasionally reaches out to touch the stars. Now, let us indulge in a grand, audacious, and frankly, slightly terrifying thought experiment. Let's dream of descent. Let's imagine that we are not content to merely skim Europa's icy, irradiated surface, nor to patiently wait for it to perhaps, maybe, burp up a plume of its secrets. No, we are humanity after all. We like to poke things. We like to drill. We like to go where, perhaps, we are not entirely welcome or equipped to survive. So, let's contemplate the colossal, almost absurd challenge of actually reaching that hidden ocean, piercing the frozen veil. This isn't like drilling for oil on Earth or even coring through Antarctic ice, though those are formidable tasks in their own right. This is orders of magnitude more difficult. First, you have to get your drilling rig, a highly sophisticated, autonomous, and probably nuclear-powered robotic probe, all the way to Europa, a journey of hundreds of millions of kilometers taking years. Then you have to land it safely on that cracked, uneven, radiation-blasted surface. A surface where temperatures make liquid nitrogen seem like a warm bath, and where the lighting conditions are, shall we say, suboptimal. Not exactly a construction site with easy access and good weather. More like trying to set up a delicate, multi-billion-dollar piece of equipment in the middle of a frozen, radioactive minefield during a perpetual twilight. Assuming you've managed that minor miracle, your robotic drill then has to begin its slow, painstaking descent through the ice shell. How thick is this shell? Well, that's one of the billion-dollar questions, isn't it? Estimates range from a mere few kilometers, say 3 to 5 kilometers, which is still incredibly thick, to a more daunting 10, 20, or even up to 100 kilometers of solid, unforgiving water ice. Imagine trying to drill through Mount Everest, but it's made of ice harder than granite due to the extreme cold, and it's actively trying to crush your drill bit with immense pressure from all sides. Oh, and you have to do it remotely, with a time delay of over an hour for communications, meaning your robot is essentially on its own if something goes wrong. Houston, we have a problem, and you'll find out about it in 45 minutes, by which time I'll either be a crushed popsicle or a triumphant, albeit very cold, explorer. The drill itself would likely be a melt probe or cryobot. Instead of physically grinding through the ice, which would generate enormous friction and require immense power. It would use heat, probably from a nuclear decay source, like plutonium pellets, to melt its way downwards. It would essentially create a small, temporary pocket of liquid water around its tip, allowing it to slowly sink through the ice under its own weight, trailing a communications and power tether behind it. A very, very slow descent. We're talking meters per day, perhaps. Weeks, months, maybe even years to penetrate the thickest parts of the shell. It's the ultimate test of patience, a geological marathon run at a snail's pace, in the dark, under extreme pressure. And what if it hits a pocket of something else? A void? A patch of surprisingly slushy, briny ice? A concentration of those mysterious reddish salts that could corrode its systems? What if the ice shifts and tries to shear off its tether, cutting it off from the surface lander, its link to home, its source of power and communication? The engineering challenges are staggering. The probe needs to be smart enough to navigate these hazards, to sense the ice conditions around it, to potentially even reseal the tunnel behind it to prevent contamination of the ocean below from surface materials, or, heaven forbid, from any terrestrial microbes that might have hitched a ride. We wouldn't want to discover alien life only to realize we accidentally sneezed on it and gave it the cosmic flu. Or worse, discover that the only life down there is the bacteria we brought with us. Talk about an anticlimax. We found life, and it has our return address. This dream of descent is a testament to human ambition, our insatiable curiosity. But it's also a reminder of the sheer brute force reality of the universe. It doesn't give up its secrets easily. It makes you work for them. It makes you invent entirely new technologies, push the boundaries of what's possible, and then it throws a few more curveballs at you just for good measure. Like, say, the immense pressure of the ice itself trying to crush your probe into a metallic pancake. Or the risk of your heat source accidentally sterilizing the very environment you're trying to study for signs of life. Oops, sorry, did I just boil the alien microbes? My bad. So, we contemplate this slow, methodical puncture into an alien realm. A delicate, high-stakes surgery on a planetary scale, performed by a robot surgeon millions of miles from its creators. We hope, with a fervent, almost religious zeal, that on the other side of that immense frozen barrier lies not just more ice or a sterile, lifeless void, but something wondrous. Something that justifies the effort, the expense, the sheer audacity of the attempt. But there's always that little nagging voice, isn't there? The one that whispers, what if you get all the way down there, and there's nothing? Or what if there is something, and it really, really doesn't appreciate being poked by a hot, metallic intruder from another world? Food for thought as you drift deeper. The universe rarely offers guarantees, especially when you're knocking on the door of its most private, hidden chambers. Let us now immerse ourselves with our ever-reliable powers of imagination in that arduous, almost infinitely slow journey downwards. Our hypothetical melt probe, our tiny emissary of warmth and curiosity, has begun its descent. It has successfully parted from the lander on Europa's hostile surface and is now inching its way into the colossal frozen embrace of the ice shell. The surface, with its faint, ghostly light from distant Jupiter and even more distant Sun, recedes above, becoming first a dim memory, then an abstract concept. The probe is a cocoon of advanced technology, but its experience, if it could be said to have one, is one of utter solitude and relentless pressure. The ice through which it melts is not like the fluffy snow of a winter's day on Earth, nor even the clear, relatively compliant ice of a frozen lake. This is ancient ice, kilometers deep, compressed by its own immense weight and the unimaginable pressures of a world constantly being kneaded by tidal forces. It is as hard as rock, perhaps harder. Its structure is crystalline, alien. It might contain trapped gases, pockets of unexpected minerals, or layers of varying density and composition, a frozen stratigraphy recording eons of Europa's history. Our probe, let's call it Persephone, for its journey into the underworld, doesn't drill or grind in the conventional sense. It radiates heat, a gentle but persistent warmth from its nuclear heart. This heat melts the ice directly in front of and around it, creating a small, temporary envelope of liquid water. Persephone then sinks, slowly, silently, through this self-made meltwater, perhaps only a few centimeters or inches at a time. Behind it, the water refreezes, sealing the tunnel, entombing the fiber-optic tether that provides its only link to the world above, its lifeline for power, if not fully self-contained, and data transmission. Imagine the darkness. Absolute, complete, and unyielding. Beyond the immediate, artificially created pool of meltwater illuminated by Persephone's own lights, there is nothing. No photons from the sun penetrate this deep. No starlight. Just the blackness of primordial ice, a blackness that has perhaps never known light. It's a darkness that presses in not just visually but psychologically even for us, merely imagining it. Makes you appreciate that little night light you keep in the hallway, doesn't it? And the pressure. As Persephone descends, meter by painstaking meter, the weight of the ice above increases relentlessly. The pressure on its hull would be immense, enough to crush a submarine designed for Earth's deepest trenches. Persephone must be built of exotic, ultra-strong materials, engineered to withstand forces that would turn steel into tinfoil. Every joint, every seal, every sensor port is a potential point of failure under such duress. It's a constant, silent battle against the crushing weight of a world. What would it hear, if it had ears? Probably not much in the conventional sense. But it would feel the ice. It would sense the groans and creaks of the surrounding ice sheet as it shifts and responds to Jupiter's tidal tugs. These stresses would propagate through the ice, perhaps as faint vibrations, subtle changes in pressure against its hull. It would be like being inside a colossal, slowly cracking glacier, a symphony of immense forces playing out in ultra-slow motion. Sometimes the universe's most dramatic events are also its quietest, its most patient. There's a certain grim determination to this imagined journey, a single-minded focus. Melt, sink, report. Melt, sink, report. For months, possibly years. The data streaming back up the tether would be readings of temperature, pressure, ice composition, perhaps detecting minute traces of salts or organic compounds frozen within the ice, hints of the ocean chemistry to come. Each data point a tiny breadcrumb leading Persephone deeper into the frozen labyrinth. The loneliness of this probe is almost existential. A tiny spark of human ingenuity, burrowing its way through an alien wasteland of ice, utterly alone, on a mission of profound significance, yet completely isolated from its creators save for a tenuous thread of light. It's a robotic pioneer, pushing into the deepest, darkest, coldest frontier imaginable. It carries with it not just scientific instruments but the hopes, the dreams, and perhaps the anxieties of an entire species curious about its place in the cosmos. Are we alone? Persephone seems to ask with every inch it descends. Is there anything else out there, or is it just more ice? And always the nagging question, how thick is this damn shell? Is breakthrough just another kilometer away, or are there 10 more to go? The probe has no way of knowing for sure until it gets there. It just keeps going, trusting in its design, its power source, and the calculations of scientists millions of miles away. It's an act of faith rendered in metal and plutonium. So, let your mind drift with Persephone down, down, into the crushing, silent, utter blackness of Europa's heart. Feel the immense pressure, the profound cold, the absolute solitude. It's a journey into the unknown, a slow, methodical descent where the only warmth is the fading sense of optimism and the faint glow of a nuclear core, pushing ever deeper into the frozen mystery. A stark reminder that exploration isn't always about glorious vistas and triumphant arrivals. Sometimes, it's about enduring the dark, the cold, and the crushing weight of the universe one slow inch at a time. The descent has been an epic of cold, pressure, and impenetrable darkness, a slow, grinding pilgrimage measured in meters per day. Persephone, our steadfast little melt probe, has endured. Its sensors have tasted nothing but ancient, sterile ice, or so it seemed. The pressure has been monumental, the silence broken only by the internal hum of its systems and the ghostly creaks of the ice around it, a world groaning under Jupiter's relentless tidal torment. But then, something changes. Perhaps it's a subtle shift in the readings from the downward-facing sonar. A different kind of echo. Perhaps the temperature sensors detect a slight, almost imperceptible rise in the ambient conditions, beyond what Persephone's own heat can account for. Or maybe the chemical sensors, diligently sniffing the meltwater, pick up a sudden spike in salinity, a taste of something not quite ice. The anticipation, even for us, merely imagining this, is palpable. Is this it? Is this the moment? And then the breakthrough. It wouldn't be a dramatic shattering, no grand explosion of ice into a waiting cavern. Remember, Persephone is melting its way. More likely, the resistance against its heated nose lessens. The ice beneath it, which has been so stubbornly solid, so unyieldingly dense for so long, begins to feel softer, slushier. Then, with a final, almost gentle sigh, the last few centimeters, or perhaps meters, of the ice ceiling give way. Persephone slides not into more ice but into liquid. For a moment, there's probably a flurry of confused readings. The buoyancy changes. The temperature stabilizes at a point significantly warmer than the ice above. Still incredibly cold by Earth standards, perhaps just above freezing for salt water under pressure, but a veritable heat wave compared to the deep freeze of the ice shell. The lights of the probe, which previously illuminated only the small, confining bubble of its own meltwater, now pierce outwards into nothingness. Or rather, into a vast, encompassing blackness that swallows the beams after a few dozen meters. Our little probe, after its long, arduous journey through the ice, is now in the water. It has breached the frozen roof of Europa's hidden world. It is floating, suspended in an alien ocean. Imagine the scene. Persephone, a small, vaguely cylindrical machine, glowing faintly with its own internal and external lights, hangs in an abyss of absolute darkness. Above it, the freshly melted hole in the ice ceiling, a tiny wound in a kilometers-thick barrier, perhaps already beginning to refreeze. Below it, only more darkness. To the sides, darkness. It is a mote of terrestrial technology adrift in an ocean that has not known sunlight for billions of years. An ocean that has been sealed away, a pristine, untouched, alien environment. Until now. Until this tiny, uninvited guest arrived. The silence here would be different from the silence of space, or the silence within the ice. In space, silence is the absence of a medium. In the ice, it was the silence of immense, solid pressure. Here, in this alien ocean, it would be the silence of liquid depth. Perhaps not entirely silent. There might be the faint, distant groans of the ice shell above, still flexing and shifting. There might be subtle currents, the slow, ponderous circulation of this vast body of water, driven by temperature differences between the warmer seafloor and the colder ice ceiling. If there are hydrothermal vents far below, as we hope, they might create their own distant, muffled rumbles, the sound of a geologically active seabed. But mostly it would be a profound, watery stillness. The pressure is still immense, of course. Kilometers of water pressing down, in addition to the kilometers of ice still above that. Persephone is built for this, but it's a constant, crushing reminder of its alien surroundings. The water itself is likely briny, full of dissolved salts and minerals leached from Europa's rocky mantle over eons. The exact composition? Unknown. That's what Persephone is here to find out. Is it like Earth's oceans? Probably not exactly. Different minerals, different concentrations, perhaps even exotic salts we're not familiar with. This moment of breakthrough is the culmination of so much hope, so much ingenuity, so much patient, determined effort. It's a pivotal point in our imaginary mission. We are no longer just speculating about an ocean, we are in it. Or at least our robotic proxy is. The feeling is one of profound triumph, mixed with a healthy dose of what now? And perhaps a little bit of, oh dear, what have we gotten ourselves into? The darkness is the most striking feature. An eternal night, only pierced by the feeble glow of our probe. This is a realm where sunlight is a forgotten rumor, a myth from another world. If life exists here, it has evolved without a sun, without photosynthesis as its primary energy source. It must rely on something else entirely. So, let yourself float for a moment with Persephone in this vast, sunless, silent ocean. Feel the transition from the hard, unyielding ice to the cold, liquid embrace of this hidden sea. Up is the frozen ceiling, a distant memory of another state of being. Down is the beckoning, unknown abyss. The journey through the ice was an ordeal. The journey in the ocean is an exploration into one of the deepest, darkest, and potentially most profound mysteries the solar system has to offer. The door has been opened, or rather melted. Persephone, our intrepid little submersible, now untethered from the ice ceiling or perhaps still connected by its vital, delicate fiber optic thread, begins its new phase, exploration. It has successfully transitioned from a cryobot to a hydrobot, a spelunker of ice to a diver of alien seas. Its mission, to navigate this vast, lightless domain, to taste its waters, to listen to its silences, and most crucially to hunt for warmth and any potential signs of life that might huddle around it. The ocean is dark. Utterly, profoundly dark. Persephone's lights cut a swathe through the blackness, but it's like shining a flashlight into the Marianas Trench on a moonless night. The beams are swallowed by the immensity. The probe moves slowly, cautiously. This is uncharted territory in the most literal sense. There are no maps, no landmarks, save for the underside of the ice roof far above, and the presumed seafloor kilometers below. Navigation would be a complex dance of sonar, inertial guidance, and perhaps even sensing the subtle variations in Jupiter's magnetic field as it penetrates the ocean. The primary target for any search for life in such an environment isn't just anywhere in this colossal volume of water. It's the seafloor, specifically areas where there might be hydrothermal vents. On Earth, in our own deep, dark oceans, far from the reach of sunlight, Entire ecosystems thrive around these volcanic oases. Cracks in the ocean floor spew out hot, mineral-rich water, heated by magma close to the surface. And specialized bacteria, through a process called chemosynthesis, use the chemical energy from these vents, compounds like hydrogen sulfide, that smell of rotten eggs, to produce food. These bacteria then form the base of a unique food chain, supporting tube worms, strange crabs, ghostly fish, all adapted to a life of darkness, pressure, and chemical sustenance. It's a beautiful, if slightly unsettling, example of life finding a way, even in the most extreme and unlikely of places. We kicked that particular can down the road earlier, but now it's staring us in the face. Or rather, it's what Persephone is hoping to stare in the face. So, Persephone begins its descent towards the European seafloor. Kilometers down. The pressure increases with every meter. The darkness remains absolute. The journey is slow, methodical. Sonar pings into the abyss, listening for the echo that will signal the approach of solid ground. The probe's chemical sensors are on high alert, sniffing for telltale plumes of those vital vent chemicals, sulfides, methane, hydrogen, the faint scent of geological activity, the perfume of potential life. Imagine the scene if Persephone does find such a vent field. After hours, or perhaps days, of descending through seemingly empty, cold, dark water, its lights might suddenly illuminate a bizarre, alien landscape. Towers of precipitated minerals like grotesque, blackened chimneys, belching out plumes of superheated, dark smoke. Actually water-thick with dissolved minerals from Europa's rocky interior. The water temperature around these vents would be significantly higher than the ambient ocean, a localized hot spring in the frigid deep. It would be an oasis of warmth and chemical energy in an otherwise barren, freezing desert. And what might we see clinging to these vents? This is where speculation runs wild, and where our human biases for Earth-like life have to be carefully managed. We probably shouldn't expect tube worms that look exactly like Earth's. Evolution is a tinkerer, not a Xerox machine. Any life here would have evolved in complete isolation for billions of years, under conditions very different from Earth's deep oceans, different chemistry, different pressures, perhaps even different fundamental building blocks if we're really lucky, or unlucky depending on how you feel about truly alien biology. It might be microbial mats, slimy coatings of single-celled organisms feasting on the chemical bounty. Perhaps simple, multicellular forms clinging to the rocks, filtering the water. Or, if we allow our imaginations a little more leash, something more complex. Something that has adapted to navigate these dark waters, to hunt, to survive in this unique, extreme environment. What would it look like? Would it have eyes in a place where there is no light to see by? Perhaps other senses, exquisitely tuned to pressure changes, chemical trails, or electrical fields. The universe has a far greater imagination than we do, and it's had a lot longer to experiment. The possibilities range from the mundane, just some very hardy bacteria, thanks for coming, to the genuinely unsettling, things that writhe and possess far too many appendages for our liking. Let's hope for fascinating bacteria, and maybe keep the writhing, multi-appendaged horrors for a different kind of bedtime story. Though this is cosmic bedtime story, so perhaps a little writhing is thematically appropriate. Persephone would deploy its instruments, cameras, spectrometers, sample collectors. It would cautiously approach these oases of alien geology, meticulously documenting everything. Every reading, every image, every captured microliter of water would be precious, a potential Nobel Prize-winning data point. The search is not just for life itself, but for the conditions for life, for complex organic molecules, for any sign that this hidden ocean is more than just a sterile chemical soup. Drifting in this abyssal realm, our tiny probe is a beacon of curiosity in a universe that, for the most part, seems content with its own vast, silent mysteries. The hunt for warmth, for these hydrothermal hotspots, is a hunt for the very engine of life in a sunless world. It's a search for a flicker of biological activity in an ocean that has been locked away, a secret kept by an icy moon for billions of years. Let the thought of that slow, patient search through the crushing darkness, guided by the faintest chemical whispers, lull you deeper into your own comfortable abyss of sleep. As Persephone, our diligent robotic explorer, navigates the inky blackness of Europa's presumed subsurface ocean, its sensors are not just looking for heat signatures or shadowy, writhing things that might make a good jump scare in a low-budget sci-fi film. It's also meticulously analyzing the water itself, sniffing out the very ingredients that might make this alien sea a plausible cradle for life. What is this primordial brew actually made of? And does it contain the necessary building blocks, the cosmic recipe for life as we know it, or perhaps life as we don't know it? Water, of course, is the primary ingredient, the solvent in which the chemistry of life, at least as we understand it, unfolds. And Europa seems to have plenty of that, potentially more than all of Earth's oceans combined. Score 1 for Europa. But water alone isn't enough. You need stuff in the water. One key set of ingredients are salts. The magnetic field data strongly suggests Europa's ocean is salty, which is good news. Salts not only lower the freezing point of water, helpful in a place this chilly, but they also imply that the water has been in long-term contact with the rocky seafloor. This interaction, this slow geological marination process, is crucial. As water percolates through rock, it leaches out minerals, sodium, chloride, making common salt, but also magnesium, sulfates, potassium, carbonates, and a whole host of other elements. These dissolved minerals are vital for life, providing the raw materials for cell structures, energy transfer, and all the complex biochemical reactions that define a living organism. Think of them as the universe's spice rack, essential for cooking up anything more interesting than plain, sterile water. Persephone's chemical analyzers would be working overtime, tasting the subtle mineral tang of this alien sea, trying to determine its specific salinity and elemental composition. Is it an Earth-like brine, or something more exotic, perhaps rich in magnesium sulfates as some models predict? The flavor profile of Europa's ocean could tell us a lot about its geological history and its potential hospitality to life. Then there are organic molecules. Organic in this context doesn't necessarily mean produced by life. It simply refers to molecules based on carbon, often including hydrogen, oxygen, nitrogen, phosphorus, and sulfur, the CHNOPS elements, the fundamental building blocks of life as we know it. These molecules can form naturally through non-biological processes. Comets and asteroids are rich in them. They're found in interstellar gas clouds. It's quite possible that Europa inherited a healthy dose of organic material during its formation, or has had it delivered continuously by impacts over eons, though that thick ice shell makes for a rather effective delivery deterrent for recent arrivals. Furthermore, reactions at hydrothermal vents, driven by the chemical disequilibrium between the hot vent fluids and the cold ocean water, can also synthesize organic molecules from simpler inorganic compounds. So, Persephone would be sniffing for methane, for amino acids, the building blocks of proteins, for nucleotides, the building blocks of DNA and RNA, or even just for simpler hydrocarbons. Finding these wouldn't be proof of life, but it would mean that the pantry is stocked. The raw ingredients are there. The Lego bricks for assembling something more complex are scattered on the floor. The third, and perhaps most critical requirement is an energy source. Life needs energy to fight against entropy, to maintain its complex structures, to replicate. On Earth's surface, most life gets its energy from the sun through photosynthesis. In Europa's sunless ocean, that's not an option. So, as we touched upon, the energy must come from chemical sources, chemosynthesis. This relies on a state of chemical disequilibrium, a difference in chemical potential that life can tap into. Hydrothermal vents are prime locations for this, as they spew out reduced chemicals, like hydrogen sulfide or methane, from the moon's interior into an ocean that is likely more oxidized, containing things like sulfates or carbon dioxide, perhaps originally delivered by comets or formed by radiation processing of surface ice that gets mixed down. Life can then act as a tiny chemical mediator, facilitating reactions between these reduced and oxidized compounds, and skimming off a bit of energy for itself in the process. It's like a tiny biological battery running on the chemical imbalances of its environment. It's a less flashy energy source than a blazing star, certainly. More of a slow, steady trickle than a gushing torrent. But for life that has evolved in the dark, it might be all that's needed. So, Persephone isn't just looking for creatures, it's assessing the overall habitability. Is the water too salty or not salty enough? Are the necessary elements present in usable forms? Are there sources of chemical energy that life could exploit? It's a bit like a cosmic real estate agent, checking off the features of a potential new home. Global ocean, check. Essential minerals, check. Organic molecules looking promising. Energy source. Yes, lovely hydrothermal vents with charming sulfide emissions, excellent. A bit of a fixer-upper in terms of lighting, and the pressure is a tad extreme, but loads of potential for the right kind of tenant. The beauty of this is that even if Persephone finds no actual, squirming Europan space squid, discovering an ocean rich in the right chemical ingredients and powered by geological energy would still be a monumental discovery. It would mean that the conditions for life, the prerequisites, are not unique to Earth. It would mean that such potentially habitable environments might be common throughout the galaxy, hidden away beneath icy shells on countless other worlds orbiting other stars. That, in itself, would be a profound shift in our understanding of our place in the universe, suggesting that the stage for life is set far more widely than we once imagined. Even if the actors haven't shown up yet. Or perhaps they're just very, very shy. Or very, very small. Or simply so alien we wouldn't recognize them if they bit our probe on its metallic backside. The universe, as always, keeps its options open. And its recipes are often surprisingly simple, even if the resulting dishes can be mind-bogglingly complex, or occasionally just a bit bland. Alright, we've established that Europa's hidden ocean might just have all the right stuff in its cosmic pantry. Water, minerals, organic molecules, and even a potential energy source in the form of hydrothermal vents. The stage seems set. The ingredients are simmering. So, the multi-billion-dollar existentially loaded question rears its head, or perhaps its pseudopod. What, if anything, actually lurks below? Are we talking about a few hardy, unremarkable microbes, quietly munching on sulfur compounds? Or could billions of years of evolution in this unique, isolated environment have cooked up something more complex? Something that might make us rethink our place as the galaxy's most interesting bipeds? Or, dare I say, something that might make us wish we'd left that ice shell well and truly undrilled? Let's start with the most conservative and frankly most statistically probable end of the spectrum: microbial life. If life exists on Europa, it's almost certainly going to include or perhaps be entirely composed of single-celled organisms. Bacteria, archaea, or their alien equivalents. Things that are small, resilient, and very good at making a living from meager chemical scraps. They wouldn't be much to look at, probably requiring a powerful microscope to even confirm their existence. Finding them would be less encountering an alien, and more detecting a faint anomalous chemical signature in a water sample. Not exactly primetime television, perhaps, but scientifically, it would be earth-shattering. Or Europa-shattering, I suppose. The discovery of even a single independently evolved microbe beyond Earth would tell us that life is not a unique fluke of our planet, that the universe is at least potentially teeming with it. That alone would be worth the trip. Even if they're just, space germs. Extremely fascinating, philosophically profound space germs. But what if evolution on Europa has had a bit more ambition? Billions of years is a long time. On Earth, it took about 3 billion years for life to go from single cells to something you could vaguely recognize as an animal. If Europa's ocean has been stable and life-supporting for a similar timescale, could more complex, multicellular organisms have arisen? It's possible. The energy available from chemosynthesis is generally much less than from photosynthesis, which might act as a brake on the evolution of large, active creatures. Think slugs, not sharks. Or perhaps things that are very, very slow, conserving every precious joule of energy. Creatures of the abyss, adapted to utter darkness, immense pressure, and a diet of chemical soup or each other. What might they look like? Well, without sunlight, eyes as we know them would be largely useless, unless they're adapted to detect bioluminescence, which is a distinct possibility. Many deep-sea creatures on Earth produce their own light. Perhaps Europa's denizens do too, creating faint, ghostly patterns in the eternal night. A silent, submarine aurora. They might have highly developed senses of touch, taste, or an ability to detect vibrations or electrical fields generated by other organisms or geological activity. They could be soft-bodied, gelatinous to cope with the pressure. Or perhaps they have exoskeletons like crustaceans but made of different materials. Appendages? Who knows? Fins, tentacles, cilia, something entirely novel. The design constraints are darkness, pressure, and efficient energy use. The evolutionary toolkit is whatever chemistry Europa provides. The results could be surprising. And perhaps, for our delicate Earth-centric sensibilities, a little unsettling. Imagine something that's part jellyfish, part anglerfish, part geological survey probe, slowly oozing its way across a vent chimney. Sweet dreams. Now let's gently wade into the murkier, more speculative, and yes, slightly cosmic horror-tinged waters. What if something intelligent has evolved down there? This is where the probability plummets dramatically, and the hand-waving intensifies. Intelligence, as we understand it, is a very specific and perhaps very rare evolutionary outcome. It requires a lot of energy, complex sensory organs, manipulative appendages, and probably some form of social structure. Could such a thing arise in a cold, dark, resource-limited ocean? It's a very long shot. But the universe is vast and old, and loves to surprise us, often in ways that make us question our sanity. If there were intelligent Europans, they would be beings of the deep, their entire worldview shaped by an existence without stars, without sky, without sunlight. Their science, their philosophy, their art, if they had such things, would be utterly alien to us. Perhaps they communicate with sonar, or by changing patterns of bioluminescence, or through subtle chemical signals. Their understanding of the universe would be based on the geology of their seafloor, the chemistry of their ocean, the faint rumbles from the ice shell above, and the colossal, ever-present influence of Jupiter's gravity. What would they make of a tiny, hot, metallic probe suddenly melting its way through their roof and shining lights where no light has ever been? Curiosity? Fear? Annoyance? Oh great, the upstairs neighbors are drilling again. And this is where the cosmic horror element can gently creep in, not in a giant tentacled monster will eat the probe kind of way, though never say never, the universe is a big place, but more in the sense of encountering something so profoundly alien that it challenges our fundamental understanding of what life is, or what intelligence means. Or the unsettling implication of accidentally stumbling into a civilization that is ancient, powerful, and perhaps utterly indifferent or even hostile to our intrusion. It's the fear of the unknown, magnified by the crushing alien environment. It's the realization that if something truly advanced exists there, we are like ants blundering into a nuclear reactor. We wouldn't even understand the danger until it was far too late. More likely, though, if there's anything more complex than microbes, it's probably on the level of, well, alien fish or alien worms or alien sea cucumbers. Fascinating, certainly. World-changing, absolutely. But probably not plotting galactic domination from the bottom of a freezing ocean. The universe tends to be more subtly terrifying than that. The true horror might be in finding nothing at all. Billions of years, a perfect ocean, all the ingredients, and just sterile water. That would be a lonely discovery indeed. A vast, empty ballroom where the music is playing but no one ever showed up to dance. So, as Persephone drifts, its lights cutting feeble swaths through the primeval dark, it carries the weight of these possibilities. From the simplest bacterium to the most elaborate, unimaginable alien entity, or perhaps just the profound silence of a lifeless, though beautiful, abyss. What lurks below? The question hangs in the cold, dark water, waiting for an answer. Or perhaps, content to remain an eternal, unsettling mystery. Let's take a moment as our imaginary probe Persephone continues its lonely vigil in the abyssal depths of Europa's ocean, to truly absorb the sheer, mind-numbing scale of this hidden world. We talk about an ocean, but that word, familiar from our own blue planet, scarcely does justice to the potential immensity we're dealing with here. This isn't just a big pond under the ice. This is a global, planet-circling body of water that could very well dwarf all of Earth's oceans combined. Think about that. All the water in the Pacific, the Atlantic, the Indian, the Arctic, the Southern Ocean, all of it, scooped up and poured into one place, might still not fill Europa's hidden sea. Europa itself is smaller than Earth's moon, about a quarter of Earth's diameter. A relatively small celestial body on the grand cosmic scale. Yet, because it's believed to have a differentiated structure, a rocky mantle surrounding a metallic core, all beneath that water layer and icy shell, and because water is less dense than rock, a significant portion of its volume could be this ocean. Estimates suggest this ocean could be, on average, 100 kilometers deep. 100 kilometers. That's over 6 times deeper than the Marianas Trench, Earth's deepest known point. Imagine an ocean so profound that our deepest trenches would be mere paddling pools in comparison. Now try to visualize that. A sphere, roughly the size of our moon, with an outer icy shell perhaps 10 to 30 kilometers thick, and beneath that, a continuous layer of liquid salt water extending down for another, say 70 to 90 kilometers before you even hit the rocky seafloor. The volume of water involved is staggering. We are talking about something in the neighborhood of 2 to 3 times the amount of water found on Earth. All of it hidden, all of it dark, all of it under immense pressure. Our probe, Persephone, as sophisticated and marvelous as we imagine it to be, is, in this context, infinitesimally small. It's a single grain of sand exploring the entirety of the Sahara Desert, if the Sahara were also pitch black, freezing cold, and trying to crush you. The chances of it stumbling upon definitive signs of life, especially if that life is sparse or localized, perhaps only around those hydrothermal vents we're so keen on, are dauntingly slim. It's like searching for a specific, uniquely colored fish in all of Earth's oceans with a single tiny submersible, with only a few years to do it. The search area is almost incomprehensibly vast. This sheer scale brings a certain humility, doesn't it? A cosmic ouch. We humans, with our grand ambitions and our powerful technologies, are still like toddlers dipping a toe into an infinite ocean. We might get a little taste, a fleeting glimpse, but the true extent, The true nature of what lies within these alien depths could elude us for generations if not forever. Every sample Persephone takes, every image it captures, is a precious, tiny pinprick of light in an overwhelming darkness. Consider the implications for any life that might exist there. If there are Europan organisms, they inhabit a three-dimensional space of almost unimaginable volume. On Earth, most life is concentrated on surfaces: the land, the seafloor, the sunlit upper layers of the ocean. But in Europa's ocean, life could potentially exist throughout that entire 100-kilometer deep water column, if it has adapted to varying pressures and chemistries. It would be a truly volumetric biosphere. The habitable zone isn't just a thin film, it's an entire world of water. And this vastness also contributes to the potential for cosmic loneliness, even if life is found. Imagine if Persephone does detect a thriving microbial ecosystem around a vent. Wonderful. But that vent is one tiny spot on a seafloor larger than the surface area of several continents. Are there other such oases? Almost certainly if the conditions are right. But how far apart are they? Are they isolated pockets of life, evolving independently, like tiny biological islands in a vast, sterile sea? Or is there some form of slow deep ocean current that connects them, allowing for a more global Europan biosphere? We just don't know. Our probe is a single point of reference in a volume that defies easy comprehension. This isn't to say the search is futile. Far from it. Any discovery, however small, however localized, would be revolutionary. But it's important to temper our expectations with a healthy dose of cosmic realism. Europa isn't going to give up its deepest secrets easily, simply because there are so many places for those secrets to hide. It's the ultimate game of hide and seek, played on a planetary scale in the dark with one hand tied behind our back. And Europa has had billions of years to get really good at hiding. So, as you drift off, let the sheer, stupefying vastness of this hidden Europan ocean wash over your mind. Picture our tiny probe, a courageous but ultimately insignificant explorer, suspended in that colossal black liquid sphere. It's a single drop of awareness in an alien ocean, a testament to our relentless curiosity, but also a profound reminder of our limitations in the face of the universe's grand, silent, and often overwhelmingly large mysteries. The search continues, one sonar ping, one water sample, one flickering image at a time, in an ocean that holds more water and perhaps more secrets than we can comfortably imagine. We've journeyed with Persephone through the ice into the dark ocean, and considered the mind-boggling scale of its potential watery domain. We've pondered the ingredients for life, the forms it might take, from humble microbe to, well, let's not get carried away with the space krakens just yet. But now, let's pull back a little, zoom out from the immediate vicinity of our imaginary probe, and contemplate the bigger picture, the truly existential splash that any discovery, or lack thereof, on Europa would make back here on our own little blue-green marble. What are the philosophical ripples, the deep, unsettling, or perhaps deeply comforting implications for humanity? First, let's imagine Persephone hits the jackpot. Not gold, not oil, but life. Even if it's just microbial. The confirmation that life has arisen independently on another world in our own solar system would be, without any exaggeration, one of the most profound discoveries in human history. It would fundamentally change our understanding of our place in the universe. No longer would Earth be the sole, miraculous cradle of biology. Life would cease to be a unique accident, a lonely singularity, and would instead become a potentially common cosmic phenomenon. If it happened twice, right here in our own backyard, then the odds of it happening countless other times, across the billions of galaxies and trillions of stars, would skyrocket. The universe would suddenly feel a lot less empty. More populated, at least with the potential for company. This would be a powerful antidote to cosmic loneliness, that lingering background hum of anxiety that suggests we might be the only thinking, feeling beings in an indifferent void. If Europa has life, then perhaps Ganymede does too, or Enceladus, or Titan. Perhaps Mars once did, or still does, deep underground. Suddenly, our solar system transforms from a collection of mostly sterile rocks and gas balls into a veritable cosmic petri dish, with multiple independent experiments in abiogenesis bubbling away. It would be exhilarating. And perhaps a little bit humbling. We wouldn't be quite so special anymore, would we? Just one example of a natural process, rather than the sole, divinely, or randomly favored child of creation. Some might find that idea unsettling, a dethroning. Others liberating. Oh good, a part of us might sigh, we're not the only ones dealing with this whole, being alive business. Now, consider the alternative. Persephone searches diligently, its instruments perform flawlessly, it explores vent fields, sips the water, sniffs the chemicals, and finds nothing. Absolutely nothing. No microbes, no complex organic molecules suggestive of prebiotic chemistry, just cold, sterile, salty water. An ocean, vast and ancient, but ultimately lifeless. What then? That, in its own way, would be an equally profound, though perhaps more sobering, discovery. It would imply that even with all the apparent ingredients, liquid water, organic compounds, energy sources, and billions of years, life is not an inevitable outcome. It would suggest that the spark of abiogenesis, that transition from non-life to life, is an incredibly rare, perhaps even uniquely difficult, event. Earth's vibrant biosphere would suddenly seem even more precious, more fragile, more of an astonishing miracle. Our cosmic loneliness would deepen. The silence from the stars would feel a little colder, a little more final. If life couldn't get started in a place as seemingly promising as Europa's ocean, then where else could it? It would be a stark reminder that the universe is under no obligation to be teeming with biology just because we find the idea appealing. Sometimes the recipe is perfect, but the soufflé just doesn't rise. Terribly inconvenient for our narrative expectations. And then there's the gray area. What if we find something ambiguous? Strange chemical signatures that could be life, but could also be some exotic, non-biological geochemistry we don't yet understand. Or fossilized microbes, evidence of past life that has since died out. That would be maddeningly tantalizing, wouldn't it? Life was here, but it left. Or we just missed it. Such discoveries would fuel decades, if not centuries, of debate and further missions, keeping astrobiologists employed and existential philosophers busy. The implications of finding complex life, or heaven forbid, intelligent life, are, of course, far more dramatic and potentially far more unsettling. As we touched on, encountering something truly alien could shatter our anthropocentric worldview in ways we can barely imagine. Could be wonderful, could be terrifying, could be both. The very definition of life, intelligence, civilization, might need a radical overhaul. We might find ourselves as cosmic primitives, suddenly aware of much older, much stranger, and perhaps much more powerful players on the galactic stage. Or we might find creatures so utterly different that communication or comprehension is impossible, leaving us with an even more profound sense of isolation. The loneliness of being surrounded by beings we can never truly know. Yes, there are others, but they speak only in quantum entanglement and find our reliance on carbon-based protein structures quaintly inefficient. No, they don't want to chat. So, every ping from Persephone, every data packet transmitted across hundreds of millions of miles of space, carries not just scientific information, but a tiny piece of our potential future understanding of everything. Are we alone? Is life common? Is the universe a barren wasteland with one lucky oasis, or a thriving cosmic garden with wonders yet unseen? Europa holds a piece of that puzzle. Its icy shell is like the cover of a book we're desperately trying to read, a book that might contain the answer to one of our oldest, deepest questions. The answer, whatever it turns out to be, will have ripples. It will affect our philosophy, our religion, our art, our science, our very sense of self. It's a high-stakes game of cosmic roulette, and Europa's hidden ocean is where the ball is currently spinning. Let that thought, the sheer weight of that potential knowledge, settle into your mind as you drift towards sleep, a tiny, questioning consciousness in a universe full of possibilities, both wondrous and deeply, deeply stark. Our imaginary journey with Persephone, our brave little probe, is drawing to a close. It has pierced the icy veil, tasted the alien waters, searched the abyssal plains for signs of warmth and life, and perhaps, just perhaps, glimpsed wonders or confirmed a stark and silent emptiness. But missions, even imaginary ones designed to lull you to sleep, must eventually conclude. The power cells dwindle, the data streams become memory, and the time comes for a slow, perhaps reluctant, ascent from those hidden depths. Persephone might not physically return to Earth. The engineering challenges of launching back through the ice, then from Europa's surface, and navigating all the way home with precious, potentially hazardous alien samples, are, well, let's just say it makes the initial descent look like a walk in the park. More likely, its mission ends there, in the dark, cold ocean, becoming a permanent, silent monument to human curiosity, a tiny, artificial fossil on an alien seafloor. Or perhaps, if its mission profile included it, it might make a controlled ascent, using its remaining power to remelt its way back up to the underside of the ice shell, to gather final readings, to transmit its last testament before its systems finally go cold. Let's imagine that latter scenario. Persephone, having done all it can in the deep, slowly rises. The crushing pressure lessens fractionally with each kilometer gained. The distant, theoretical seafloor recedes below into utter blackness. The only reference is the ice ceiling, growing marginally closer, detectable by sonar, a vast, uneven roof to this hidden world. The probe is, in essence, returning to the boundary, the interface between the liquid and the solid, the known, relatively speaking, and the profoundly unknown. As it approaches the underside of the ice, it might find a different environment than the deep ocean. The water here could be colder, perhaps fresher if there's a slow process of freezing and melting occurring. The ice itself, viewed from below, might be a landscape of inverted mountains and valleys, sculpted by currents and temperature variations. It would be the last view Persephone has of this alien realm, a final lingering look at the strange, beautiful, and utterly hostile environment it has so briefly inhabited. And then its final transmission. A flood of data, images, sensor readings, the culmination of its long, lonely sojourn. This data, traveling at the speed of light, takes over an hour to cross the interplanetary void, to reach the eager antennas and anxious scientists back on Earth. An hour of waiting, an hour in which Europa's secrets, whatever they may be, are already known to a tiny dying robot, but not yet to its creators. There's a certain poignant irony in that, isn't there? The messenger knows, but the recipients must wait, suspended between ignorance and revelation. Once the final bits of data are sent, Persephone's mission is truly over. Its lights dim. Its systems power down one by one. The faint warmth it generated fades, and the ambient cold of the European ocean, or the ice shell if it has re-embedded itself, reclaims it. It becomes still, silent. A tiny, frozen speck, indistinguishable from the icy debris, its purpose fulfilled. It has left Europa's deep, dark mysteries largely intact, of course. One probe, however sophisticated, can only scratch the surface, or rather, the subsurface, of such a vast and complex world. But it has given us a glimpse, a taste, a set of tantalizing clues that will fuel scientific inquiry, philosophical debate, and indeed, cosmic bedtime stories for generations to come. As we too withdraw from this imagined journey, let's gaze one last time at Jupiter, the grand, indifferent architect of this icy, watery enigma. It hangs in Europa's sky, a colossal, swirling presence, its immense gravity still kneading its little moon, maintaining that hidden ocean, utterly unconcerned with the tiny probe we sent, or the profound questions we ask. Jupiter was doing this for billions of years before we existed, and it will continue to do so for billions of years after we're gone. There's a certain stark comfort in that cosmic persistence, that grand, unblinking indifference. Our anxieties, our triumphs, our fleeting discoveries, are just tiny ripples on its immense, ancient surface. Europa too will continue its slow, cold dance. Its icy shell will continue to crack and reform. Its hidden ocean will continue to slosh in the darkness. Whether it harbors life or not, it remains a place of profound mystery, a testament to the strange and wondrous ways the universe can assemble itself. It's a reminder that even in the most unlikely hostile corners of our solar system, there can be beauty, complexity, and the enduring, irresistible allure of the unknown. The secrets are still there, simmering in the dark. And perhaps that's the most relaxing thought of all. The universe still has plenty of mysteries left to solve. We don't need to have all the answers tonight. We just need to sleep. And so, our little exploratory dive into Europa's hidden, frigid heart comes to a gentle close. You've journeyed across the vastness of space, skated on radioactive ice, and plunged into an ocean of unimaginable darkness and pressure. You've pondered the chemistry of alien seas and the unsettling, or perhaps wondrous possibility of what might swim or ooze, or simply be in those lightless depths. It's a lot to take in, isn't it? The sheer scale of it all, the mind-bending science, the existential weight of searching for life, or confirming its absence. The universe, as we've seen tonight, is not always a warm, fuzzy blanket. It's often cold, indifferent, and filled with places where you'd last about 3 seconds without a very specialized and probably very expensive suit. It's a place where beauty and lethality often go hand in hand, where wonder is frequently juxtaposed with a distinct sense of nope, definitely don't want to go there for my holidays. But that's alright, because tonight, right now, you are safe. You are warm. You are far from the crushing pressures of Europa's ocean, far from Jupiter's relentless radiation. Those cosmic realities, as stark and fascinating as they are, can remain out there, swirling in the grand, indifferent ballet of the cosmos. Here, in the sanctuary of your mind, as you drift deeper and deeper into sleep, you can let them go. Let the image of Europa, that gleaming, cracked pearl with its secret ocean, be a reminder of the infinite wonders and the profound mysteries that still await. Let the thought of its dark, silent sea be a strangely calming presence, a vast, quiet space where the everyday worries of your world can dissolve and fade away. The universe is immense, its truths often harsh, its beauty sometimes terrifying. But in that very vastness, in that stark reality, there is also a peculiar kind of peace. A peace that comes from accepting our smallness, our fleetingness, and the wondrous, absurd, and ultimately unknowable nature of it all. So breathe deeply. Let go of the day. Let go of the journey. You are drifting now, not through an alien ocean, but into the soft, welcoming depths of sleep. Sweet dreams. Or, at the very least, profoundly deep and untroubled ones. The cosmos will still be there when you wake, with all its beautiful, terrifying, and endlessly fascinating secrets. But for now, just sleep.